but it's good to know to use MATLAB as well. Anybody remembers the trick that we employed when we had complex conjugate roots? Yes, yes.
Conjugate of conjugate.
You could do that, that's pretty painful though. Yes, yes.
Plus minus thing, so you get the S on its own as the
Fantastic.
sine cosine.
Beautiful. Gorgeous. Alright, so I just have plus sigma minus sigma, then I say isolate the S plus sigma. I know the inverse Laplace of that should give me a cosine. All the rest of the garbage put together should give me an inverse Laplace of sine. Right? So we will do that and call it quits. And you got to understand, a lot of these developments took place before the birth of MATLAB and things. So people painstakingly calculated these numbers by hand, and they had to be really precise because lives of people were dependent on that. Okay? So it is important to know these things. All right. So if I have x of s, this is now x naught s plus sigma, last minute, s plus sigma or zeta omega n, I should say. Of course, it's evident there, but I'll just write it as zeta omega n here. S plus zeta omega n, which we called as sigma, plus omega d square, plus all the rest of the terms put together. I'm going to collect them all together. So that's v naught 2 zeta omega n x naught minus x naught zeta omega n divided by s plus zeta omega n whole square omega d square, and for that last term I will multiply by omega d and divide by omega d. Okay, so multiply by omega d and divide by omega d, so that if I take the inverse Laplace of all of these things, the inverse Laplace of the first big bracketed term will give you the following. So x of t is now x naught e to the power whatever is a shift, that's minus zeta omega n t, cosine omega d times t. That's the inverse Laplace of the terms inside there. The x naught remains there. When I take the inverse Laplace of the second term, the things I am concerned with are the following. Only these guys. The inverse Laplace of that gives me a sinusoidal term with an exponential change. If you have a question.
What happens to the minus sigma or the minus zeta?
Oh, that's right here. That's right here. So that's x naught times sigma. Actually, I should maybe write it down here. So this is minus x naught times sigma. Okay, then the inverse of that gives me the following. So plus, so 2 zeta omega n x naught minus x naught zeta omega n is just x naught zeta omega n. So this is v naught zeta omega n x naught e to the power minus omega n t sine omega dt. Or more simply, because I have 1 more minute left, is just a cosine omega dt, b sine omega dt, all of this multiplied by e to the power minus zeta omega n t, where a is x naught, and this creature. Next lecture, I'm going to start off from this particular line, okay, or its precursor, and we're going to start looking at system identification. Given an experimental data, how do you identify the system?